Alright, well so far everything we've done has involved simple beams. Your beams are structural members that are subject to bending forces. So the simple beam supported at both ends is going to bend in the middle, as we've already seen. A cantilever is a type of beam that's supported at one end only. An example most of you are familiar with is a diving board. When nothing's put on it, there's no load, it sits perfectly straight and horizontal. But as soon as the diver moves out along the edge of it, it starts to bend down, and the more load you place on it, the further down it bends. A cantilever principle is used in bridge construction as well as other things such as sports stadiums, roofs, balconies, carports, aircraft wings, shelves, doors, castle drawbridges. One of the main limitations in making arched bridges is that both sides of the arch act as a cantilever until the span's completed. Alright, so that's where you put the keystone in. We're going to look at several bridges. We're going to look at a couple today in this next part with Skill Builder 7. Now, two types of cantilevers used in bridge designs I need you to be familiar with. First one is called a hinged cantilever. Hinged cantilever, like the tower bridge. It's a beam that's attached to a support by a hinge joint, which allows the beam to rotate around the bridge, around the hinge. And I want you to look at this and investigate it and look it up. Again, it's called the tower bridge. And the second type is called a fixed cantilever. A fixed cantilever is one such as the Firth of Forth. And I want you to look this up as well, and we'll discuss this one later as well. The Firth of Forth is a rail bridge, and there's also one called the Astoria Bridge, and then cable stayed bridges such as the Dames Point Bridge. These are ones that we're going to look at, some of these fixed cantilever bridges. We're not going to have time to look at the Tower Bridge in this investigation. But in fixed cantilevers, the beam is fixed on its support in such a way that it's unable to rotate. A load's placed on the free end of the beam that tries to make the beam rotate in the direction of the applied forces, but because the fixed end, or root, cannot rotate, the beam bends downward instead. The forces exerted on the root are dependent on the size of the load, measured in newtons, and the distance the load is applied from the root, measured in meters. This turning force is called the bending moment and can be calculated as follows. Your bending moment, which is measured in Newton meters, is equal to the force applied times the distance. And your force is measured in newtons, distance is measured in meters. Okay? A bending moment, anything that's a moment, we're talking about a rotational force or a torque, and it's measured in force times distance. That turning force times the distance that you're applying it from the root. So if we have our bridge, here's the foot, and then here's the actual bridge itself, and it's a fixed cantilever. So if we apply a force here, your bending moment is the amount of this force, F, and the distance it is from here, D. So that force times that distance will give you your bending moment. Now, as in previous skill builder activities, there's a lot of opportunities to look at new vocabulary and new things, so I want you to be aware of these new vocabulary terms that come up. Y'all have fun.